So, okay, I think I'm good. Sorry for being late. I have a little problem with my webcam and I apparently can't seem to make it work. But we're going to stream with just my screen tonight, I guess. So, welcome to the stream for Exorcism. This is a stream for Exorcism's 12 and 23 challenge and the month of March, which is named Mechanical March. And this month, Exorcism focus is on system languages. So tonight we're going to be streaming a little bit of C++. Uh, for those who don't know C++, I guess you all know the name of the language because it's an ubiquitous and very old language. So most people know at least what C++ is about. But for those who've never used C++, we're going to be showcasing a few problems from the Exercism C++ track tonight, and trying to solve them using C++. So hopefully we're going to be showcasing a few of the features of C++. So a little bit of history. C++ is a very old language. It's a compiled language. It's a systems language because you write your code in C++ and then you compile it and link it into a platform specific executable that can be run directly in the machine. So basically you compile it into machine code. So for those of you who are not used to this because you've been working with the dynamic languages like JavaScript or Python, C++ is on the opposite side of that spectrum. So the idea is to compile it to machine code so that it runs really fast. And C++ allows you to have pretty much direct access to the machine, the memory, and a lot of the different things that you can do in a computer. And this is a double-edged sword. So it allows you to have a lot of power with what you do, but it's also comes with a lot of responsibility, as we can paraphrase. But you must be very careful about what you do because C++ has a reputation for being a language that is subtle to learn. I think it's true. It's probably I would say for all the languages that I have personally learned, it's probably the one that is the most difficult to master because there's are lots of very subtle things in C++ that you learn over time, and it can sometimes bite you when you don't know them. So, but it's very powerful languages. It's used very in various places around the world. It's popular in video game development because it's fast. It compiles to very fast code. It's a lot of video game libraries are written in C++ and are used in C++. It's also very popular for writing code on very small computers, microcontrollers, and stuff like that because of its small footprint. You can write programs that use very little memory, and even though C, the classic C language, might be more used in some places, C++ is also used because C++ is based on the another older language, which is C. So C++ is basically an object-oriented version of C. So it's a superset of C. It's normally every legal C code also compiles as legal C++ code, but the opposite is not true. So if you compile code with a C++ compiler, you get the advantage of having all the C++ tool set. So I don't know if you have any questions. I feel free to ask in the Twitch chat as I go along. So I am now on the Exorcism website, and we're going to go. For those of you who don't know the Exorcism website, it's a website that allows you to learn programming languages. It doesn't really allow you to learn programming per se. It basically assumes that you know how to program, perhaps in one language, and allows you to learn other languages. So if you're familiar with one, you can learn another. So it's divided into tracks, and each language has its own track. So if I go in the C++ track, there seems to be a little lag. Maybe my computer is too slow for this. So in a language track, there are multiple exercises, as we can see here. And basically, when you join a track, let me go back just a bit. The first exercise that you will be completing is called Hello World. It's a classic in programming to write a program that says Hello World on the console. So this is true of every language track on Exercism, and it's always the first exercise that you need to do to unlock the rest of the track. So in this case, I already completed the the Hello World exercise so that we can see other exercises, because it's not really interesting just to print a Hello World string. So okay, so the first exercise that I wanted to show you is called Collatz Conjecture. So if we go to to that exercise, basically the idea is uh, I don't know if it's I hope that my text is big enough. Not sure. Let me just zoom a bit, maybe. It's not very. The website doesn't seem to like it when I zoom too much. So let me just stay like this. Okay. So the Collatz conjecture problem uh, is based on a conjecture that says that if you have a positive integer n, you start with that integer, and if it's even, you divide it by 2 to get n divided by 2. Otherwise, if n is odd, you multiply n by 3 and add 1. So you get 3n plus 1. So you repeat this process indefinitely with the new number that you obtain. And the conjecture states that no matter which number you start with, you will always reach 1 eventually. So the goal of this exercise is to write a program to determine the number of steps that are needed to reach 1, starting with a specific number. So there's an example that says that if you start with 12, you will get the following sequence. 12, it's even, so you get 6, you divide it by 2, you get 6, which is also even, so you divide it by 2, you get 3, and etc., etc. So since 3 is odd, it's 3n plus 1, so you get 10, etc. So you see all the steps, and eventually you reach 1 here. So you need, if you start with n equals 12, you need 9 steps to reach 1. So in this example, the program that we are going to write is expected to to return 9 if the input would be n equals 12. So on Exercism, there are two ways to solve the problems. There's a built-in editor that you can use if you want. So it's a basic text editor. It has a few features like syntax coloring and a few bells and whistles. And it's cool because you can just start it inside your browser and edit your code. And if when you're done, you can just run the tests, build your code, run the tests, and see what comes with it. Tonight, we're not going to be using the editor because I myself prefer to use a local editor that I have on my computer. So there's a, in order to work locally, there's a CLI tool that you need to download, which allows you to download the exercises. So if I click here, I will copy the command line, the command that is needed to download the exercise. So it's the tool is called Exercism. It's probably too small for you to see here, but it says Exercism download and then minus minus exercise equals Collatz Conjecture, and the track is CPP, C++. So if I run that command, the Exercism CLI tool will download the necessary files to a folder called Exercism in your home directory. So the goal is not to teach the Exercism CLI tool, so I will skip that part real quick. And in order to work in C++, you can work in C++ basically in any editor, because C++ is a very, uh, let's say, agnostic language in terms of toolset. You can use the various editors. You can even write in Notepad if you want, or any text editor like Vim or anything like that. Uh, Myself tonight I'll be using Visual Studio on Windows. I'm using Windows, so Visual Studio is a popular IDE on Windows to write .NET code and also C++ code. So one cool feature of Visual Studio is that the Exercism tools C++ track uses a tool called CMake in order to build your project, and Visual Studio has a built-in CMake support now. So it didn't at first, but now it does support CMake. So let me just, whoops, sorry about that. So you just go here and open a folder, and then you have to navigate to the folder. You have the folder here, which is named Collatz Conjecture, which was downloaded by the CLI tool. So if I open that folder and select it, so if you see that part of my interface is in French, it's because I'm a native French speaker, so don't mind the, the French. So if I open that, automatically Visual Studio will start some background tasks to prepare the CMake project and create the necessary files. If I open the output here, we can see that it works with in the working directory, and it's actually right. It's not building the project yet. It's not compiling the source code, but it is preparing the project in order. It's generating the necessary files so that we can work with this project in Visual Studio. So if you use another platform, you might be using an IDE that doesn't have a built-in CMake support, like I don't know, Vim, for example. I'm not a Vim user, so sorry if that's incorrect. But you can run CMake on the command line. It's not necessary to have a built-in support in an IDE, but I myself find it useful in that. On every exercism track, there are instructions on how to install what is needed to solve the exercises locally. So install the compiler for the language if there's a compiler, or the interpreter. So in the case of the C++ track, there are instructions to install CMake and a C++ compiler on your platform. So depending on if you're on Linux or Mac OS or Windows, it will be different. So on Windows, the instructions recommend that you use Visual Studio, but you can also install the tools locally if you need. So now that the project is built, we can actually look at the file. So every every uh, exercise has a project that contains 3 files basically. There's a file that's these files are named after the specific exercise. Let me see if I can zoom a little bit, because I'm looking at the screen on Twitch and I find that my screen is not as small as I would have hoped. Sorry, I will be let me see if that helps. I think it does. Okay. So if I open the file that's named Collatz Conjecture.h, we can see here that this is a header file. So if you come from any other language, uh, you will probably be surprised by the fact that in C++, we usually split our code into two files. For every source file, there's also a header file. So the idea is that the header file is the file that declares the interface to your code. So it's the function declarations, class declarations, new type declarations, constants, etc., etc. And the source file, which is usually a .cpp file, contains the actual implementation. So why are we doing this? This is because of the way that the C++ language is built and the way that it compiles the code. In C++, every single source file, every single .cpp file is actually an independent unit that is compiled completely independently from every other file in your project. So this is different from pretty much every other compiled language that exists on the planet right now. So be it Rust or Java or anything like that. Most of the languages actually compile a project in as a whole, and they don't use two files for every source code unit. So this is a little strange for newcomers when you learn C++ at first. So here we have a file that contains a namespace declaration. In C++, there you see here it says namespace Collatz Conjecture, and there's an opening bracket. So what namespace is it's a way to separate code into different logical units if you want. It's a way to avoid name collisions. So if you have a function that's named foobar and there's another function that's named foobar in another library, if you didn't use namespaces, they would collide and the compiler would not know which one you wanted to call when you called it. So it's a good idea to use namespaces, and Exercism promotes that by using a namespace in every single of its project by default. There's a namespace called std, which is the namespace for the standard library. So this is the header file, and if we look at the source file, which is called classconjecture.cpp, it's basically just an empty namespace declaration. And there's a third file that's called Collatz Conjecture test. If I open it, we see that it contains the actual test cases that we need to be that will be run when we execute our build, and that they expect our code to have a certain signature and to return a certain result when they pass a certain argument. So, eh, like all exorcism problems, usually the test cases are divided into. There's only one test case that's enabled by default, in and the other tests are protected by a preprocessor directive that says if the exorcism run all test macro is defined, then I'll include them, but by default, it's not defined. I will not be talking about the preprocessor tonight because it's a complex topic that is a little bit alien to possibly many people who are not used to C++ or C. Uh, Basically, the preprocessor is, to be very quick, uh, when you compile a C++ file, the first step is to preprocess it. So every single preprocessor directive that starts with a pound hash symbol like that is that's a preprocessor directive. So the preprocessor actually preprocesses and modifies your source file by doing various operations, and then it's sent to the compiler. Uh, that's the way that is to include. For example, when you want to include a new header file, you use an include preprocessor directive, and you specify which file to include. And basically, what the preprocessor does is that it reads the file that you include and just pastes it inside your source file, as if it was just pasted right there in your source file. There are other much more complex preprocessor directives, and usually using the preprocessor is a very C is a good way to do things in C, but it's discouraged to use it too much in C++ because there are more expressive ways of working with things. We have to use it for include files and stuff like that, but we try not to use it to define like macros or constants or stuff like that. We prefer to define functions. So let's look at the test case. Here we have a red squiggle on the require because it says there's an error here that says that namespace Collatz Conjecture has no member named steps. So from that line, we infer that we have to implement a function named steps, which takes the integer n that was specified in the problem definition and must return an integer. So let's do that. So in order to define a function in C++, it's a bit like in if people are familiar with Java or other programming languages that have inherited their syntax from C++ will recognize this. So you first declare the return value of the function, which in my case will be int, and then you write the name of the function. Here it's steps, and between parentheses we can actually uh, write the function parameters. So in our case, the function has a single parameter, which is of type int, and let's name it n because it's what was specified in the problem definition. And then we use a semicolon to end the line. So every single a statement, not necessarily line, but every single statement in C++ must end with a semicolon. That's how the compiler knows that you want us to end the statement and begin a new statement after that. It's actually possible to write several statements on the same line with semicolons, but it's pretty much unreadable. So most people do not do that. So as I mentioned, this is the header file. So in the header file, we're just declaring the interface to our code. So this is just the function declaration. So it's not the function itself. It just declares that somewhere we're going to be defining a function named steps with a single parameter of type int and returns an int. So if we copy that and go back to our actual source file, which is a .cpp extension, we can start working on the actual implementation of the function. So I will paste in my declaration, but instead of doing the semicolon here, I will open a block, which is between brackets. So C++ uses curly brackets like that to identify blocks. So when you define a function, the function body is a block. But inside the function body, you can have other blocks. For instance, if you do conditionals like if or stuff like that, you can open other blocks. And it's even legal to open blocks that just for the sake of it, if you wish, I could then open a block here and write some code and it would be legal. There are reasons for that, but we're not going to be delving into them right now. So just just to mention that when you see curly braces, it's a block. So every single place when the compiler expects a single statement, you can actually open a block using curly braces and write several statements inside the block. Okay, so let's think about our problem here. The problem is that we are past the integer n, and we want to compute the number of steps that are needed to reach 1 by applying the Collatz conjecture. So let's start by declaring a variable to count the number of steps. We'll call it s. So I write the type of the variable, which is an int. Int is an integer, the basic integer type in C++. I didn't explain that at first. C++ has many integer types. There are signed integer types like int, which can be positive or negative. There are unsigned integer types, which can only be positive. You cannot store negative numbers. And there are integer types of various sizes. By default, int is an integer type that stores 4 bytes, that is stored in 4 bytes of memory, which means that it can go from minus 2 billion to positive 2 billion. I think I'm not really sure what the min max is, but there's a limit to what you can store in an int. So if you're dealing with very large numbers, sometimes it goes it overflows, as we say, and you have to store them in different in a bigger type of integer, which would be, for example, a 64-bit integer stored in 8 bytes, and etc. But here an int is sufficient. So we'll initialize the number of steps to 0 by writing equals 0. So that's an initializer. So basically, it tells the compiler that we want to declare a variable named s that's in the scope of the function, and that's initialized at 0. Then what we want to do is we start with n, and we want to go to 1. So basically, what we're going to do here is write a loop. So the loop that I'm going to use is a while loop. This is in a lot of different languages. We have that. So we have that in C++ also. So if I write while, and then I write a parentheses and write a condition. So I will just say while n is different from 1. So where we want to loop until n equals 1. So while n is different from 1, we want to be continue and loop until we reach 1. So different from is actually written like that in C++ for that's common in many languages, but it's uh, an exclamation point before the equal. So it says unequal. And after the while, the compiler expects a statement. So again, I will open a block here to write several statements. So inside the while loop, we need to check if n is even or odd. So there's no function to do that natively in C++. Some languages do have such a function, but there's a really easy way to know that. It's whether or not it's divisible by 2, evenly divisible by 2. So I can write a conditional if n modulo, which is the percent sign, 2 equals 0. Here, what I'm writing is I'm writing an if statement, which is a conditional. So uh, if the condition that I'm writing in the parentheses is true, then it will execute the statement, and there can be an else, etc., like in many languages. So the percent sign here is the modulo operator. So basically, it says that if the remainder of the division of n by 2 equals 0, meaning if n is divisible by 2, meaning if n is even, then what I want to do is divide it by 2. So I could write it like that, like this: n equals n divided by 2. The slash here is the division operator in C++. So this is basically what I'm telling the compiler is compute the value that is n divided by 2 and store it in n. The equal sign is the operator to store the result in n. There's not another trick that we can actually use is that there are assignment operators that combine the assignment and the computation. So I can write it like this. Slash equals means take n, divide it by 2, and store it back into n. So this is common in C++. You will see such assignment operators in different places. There are lots of them, like plus equal, minus equal. Basically, every single arithmetic operator has a corresponding assignment operator with it. So it's I guess it could be it depends on whether or not you're used to that, but it can be more compact and easier to read. So if is even, we want to divide it by 2, and then we will use the else statement to write another block that will be executed if n is odd, which is to multiply n by 3 and add 1. So I want to write n equals n multiplied by 3 plus 1. In that case, I will not be using a combined assignment operator because it's not really there's not really a nice way of doing it. So here we have the conjecture. So for a single step, we check if it's even or odd. We do the computation. And then for every loop, every time the while loop executes, basically when you reach a while, it checks the condition. If the condition is true, it executes the statement, the block here, and then it checks the condition again. So after every single pass of the loop, I want to increment the s counter, which counts the steps. This can be done with the increment operator, which is plus plus. And if you're coming from a language that has such an operator, but you've seen it used like this, after the variable, so s plus plus, just know that in C++, there are two different kinds of increment and decrement operators. There is a pre-increment operator and the post-increment operator. Basically, it depends on whether or not the operator returns the new value or the old value as its result. In our case, it doesn't matter. So we could use either one. Usually in C++, you will see the pre-increment operator used much more often. And the reason for that is that when your value, the value that you're incrementing is not actually a primitive type like int, but an object, then the pre-increment operator is usually faster. It's usually yields better performance. So now we have a loop that applies the conjecture, counts the number of steps. So the only thing that's remaining to be done is to actually return our number of steps when we reach 1. So it's as simple as writing return s. So return is the keyword that we need to use to return a value from a function in C++. Contrarily to some other programming languages like Ruby or Rust, C++, in C++, a function does not automatically return the value of its last statement. We must explicitly return a specific value, and it's legal to return in the middle of the function. So there can be many return statements in a function. It's legal. So if we did everything right, this should pass the test. So I will save this. And here what I will do is I will build my project. And the way that the Exercism C++ projects are constructed is that when you build a project, it compiles your code and it also runs all the tests. So if I do that, it should build and then run the tests. So we'll see if our implementation is actually correct. So yay, it says all tests passed, one assertion in one test case. So basically now we have a single test case because the other uh, tests were commented out by the preprocessor directive, were excluded. So if I want to run all the tests, what I usually do is that I just remove the preprocessor directives and just include every single test. Another way of doing it that is might be popular among some users of Exercism is to enable one test at a time, just to know if it works correctly. For simple exercises like this is usually not necessary, but for more complex examples where there are different cases to implement, it can be useful. So if I enable all the tests and I build my project again, we will see if my code passes the new tests. Sorry, my computer is not very fast, so I'm a cordonnier mal chaussé, as they say in French. I work in computer science and I have a very slow computer, which is a shame. So basically what's going to happen here is that we're going to see that some tests do not pass. And we will be able to check what tests are passing and what tests aren't passing, and what we can do about it. I'm a bit concerned if my computer hasn't frozen right now because it's taking a lot of time to compile this. So that's a bit weird. Sorry about that. So let's just go while my computer is thinking about building the. Let's just look at these tests and understand what went wrong. So basically, the we forgot something. There are tests at the end that validate error conditions. So if the steps function is called and what is passed is a number like 0 or even a negative value, then this the this doesn't make sense. Like you can't start from -15 and expect to use the conjecture to reach 1, because negative values don't work with that conjecture. So what the test actually expects us to do, it says required throws as, and the second argument is a domain error. So what the test is expecting us to do is that it expects us to check the value, and if the value is invalid because it's negative or 0, then we need to throw an exception. Uh, Exceptions are the classic way of dealing with error conditions in C++. It's also commonly used in many languages like Java or others. Other languages like Rust or even other. I'm not entirely sure of all the languages that exist, but other languages have other ways of dealing with the error conditions. I think Go has a different way also. There's no, I think there's no exception in Go. But in C++, there's something called exception handling. Exception handling is basically when you detect an error in your code, you can throw an exception. This will interrupt the flow of the program, and it will return from all the methods. It will unstack the functions that were called until it reaches a point where there is a catch statement that catches the exception and looks at it and acts on it. Here, the required throws as a macro that is used in the test actually does a catch. So it calls the method, it catches the exception, and it makes sure that the exception is of the type called std dot dot uh, domain error. So domain error is a class that's in the standard C++ library. It's a base exception class for errors that apply to your specific application domain. Usually what we want to do with it is to subclass it into our own error classes, exception classes. But here it's a bit unwieldy, so we're just going to use it as is. So what we want to do is we want to go back to our code. And at the beginning of the function, we want to add it a check if n is less than or equals to 0. We want to throw the exception, which is done with appropriately the throw statement. So here we want to throw a domain error, which is I will prefix it with the std namespace like this. Now there's a red squiggle. Why is that? Because it doesn't know what the domain error uh, class is, because it doesn't know about it. We didn't declare it. So what we have to do is actually include a file that's called std accept, which is the file from the standard library that defines the various classes, the various exception classes from the standard library. So here it's still in red. So if we check what the red squiggle is, it says no incentive constructor domain error matches the argument list. Basically, I made a mistake. I forgot about that actually. Uh, Domain error expects us to pass an error message when you throw an exception. So let's write an error message that says n must be positive. For instance, it doesn't really matter here because the test doesn't actually match the error message, so it just checks what the exception type is. So if we do that, we should be throwing the right domain error, and the test should have what is expected. Now, I'm sorry, my computer is incredibly slow tonight. I don't know what's going on, but so here we have the complete example of what we could do to implement the Collatz conjecture problem in C++. We've It's already 8 o'clock here at my time on the east coast of Canada. So I think we'll stop here for tonight, and we will. I will try to stream C++ again later in the month, and maybe look at a more complex example of another problem like that's called binary search. That's actually uh, will allow us to demonstrate other features of the C++ language. So in conclusion, if you want to learn the C++ language, the Exercism's website is a great place to start. Should you learn the C++ language? That's a good question. If you want to work in a domain which is where C++ is heavily used, like video game development or embedded development on small microcontrollers and stuff like that, then yes, you should definitely be learning C++. But you must also know that C++ has some kind of a bad rap when it comes to security, because it's possible to do things in C++ that are very dangerous, and the compiler will not really stop you from doing so. It's a bit strange that I'm saying this because I'm streaming I'm doing a stream on C++ in Mechanical March month, but I must be upfront with the people. So it's possible to write safe C++, but one must be careful not to use the dangerous features of the language. It's an old language that was designed at a time where security was not as important a topic as it is now. And other more modern languages have tried to tackle that issue. The only problem is that some of these languages have not caught on really because they're not as fast as C++ when they're C++. When you write really good code in C++ and compile it, it's really, really fast. So it's difficult to move to another language for some people because it writes very small programs, small memory footprints, and they are really fast. And so all these conditions are the reason why C++ is still very popular in parts of computer science. Uh, so I will conclude this here. Thank you for listening to my stream, and hopefully you will catch other people streaming on the Exercism channel later this month. I think that there are people streaming Rust and Go, and there's even a recording of somebody streaming the V programming language, which I don't know about, but it's fun to learn new languages. So have fun and good night.